Welcome to Mayfield's Code Corner. My name is Justine Sanchez. I'm the Solar Plus Storage Program Director for Mayfield Renewables. And today I'm covering the energy storage fire codes timeline. I think this is an interesting topic because when I first got into looking at the fire codes for energy storage, I was thinking that all these codes are brand new and that's why we're talking about them. But as I dug a little deeper into the history of the fire codes, which is actually provided as an annex in the NFPA 855 document, Annex F. They actually walk you through how these energy storage codes began, when they began, kind of why they began, and how they've evolved since. And I think it's kind of a cool topic. And the first thing I realized is that energy storage, stationary storage, has been covered by the Uniform Fire Code since 1997. Okay, so that's almost 25 years of actual codes that have been implemented, although it was really only for commercial applications and only for vented lead acid batteries, VLA batteries, which are the flooded lead acid batteries, since 1997. And back then it was 100 gallons of electrolyte and up is what you had to have to be regulated. And there was topics or the items that were covered were things like safety venting, okay? We're talking lead acid, flooded lead acid batteries. We want to ventilate that gas that is released when they're charging and so on. Room design and construction was covered. So rooms that contained stationary storage systems had regulations around them, like fire resistive ratings within the walls. And those rules were covered actually in the International Building Code. How do you build a wall structure to contain fire? So there's specific specifications are detailed in the IBC in a certain table and section back as far as 1997. And there was also rules about spill control and neutralization. Remember, flooded lead acid batteries, what they're regulating here. Ventilation again. Signs. We want to warn folks that there's energy storage within this room. And so you have to have signs and seismic protection for areas that are, prone to earthquakes and smoke detection. So that's for 25 years now. We've had these rules in play for a specific chemistry and amount of electrolyte that we were dealing with. Moving forward, every 3 years, there's a new code that's released, and with it, different things are covered. So when we moved up to 2000, actually what was the Uniform Fire Code is now the International Fire Code and the International Building Code. And so those regulations that started in the UFC are now taken over by the IFC and the IBC. And the big change that happened here when it comes to the actual rules was that they reduced the amount of electrolyte that you had to have to be regulated. It's down to 50 gallons and up. Just to let you know, what does that mean, 50 gallons of electrolyte? Well, because I don't really measure my batteries in terms of gallons. I think in terms of kilowatt hours. So when you're talking about a lead acid battery, that's about 70 kilowatt hours of lead acid batteries that you had to have before you were getting regulated. Moving forward into 2003, what were the changes here? Well, now the expanded coverage to not just flooded lead acid batteries, but also to sealed batteries. And for the first time, the NFPA 1, which is a different fire code, which pertains to areas that don't go by the IFC, but they go by the NFPA 1. Well, now they started covering energy storage systems as well. And that was back in 2003. But their coverage or their rules only pertain to vented lead acid batteries at that point. Moving forward to 2006, this is where they started adding different types of chemistries. This is when we started talking about NiCads and for the first time, lithium-ion batteries. And so in this case, to be regulated, you had to have 1,000 pounds of lithium-ion batteries. Once again, I don't deal in pounds for my battery systems. I deal in kilowatt hours. So what that meant was basically between 50 kilowatt hours to 100 kilowatt hours of energy storage, lithium-ion energy storage is what you had to have to be regulated. Why is there a range? Well, those of you that know about lithium-ion battery chemistry know that certain chemistries are more energy dense than others. So like nickel, magnesium, cobalt is a high energy dense battery. So you need less of it, less pounds of it to create a certain kilowatt hours. Whereas LFP is less energy dense. So lithium iron phosphate batteries And so you actually need more weight, more pounds of that chemistry to create the same amount of kilowatt hours. So back then they went by pounds, and the pounds to be regulated equated to essentially 50 to 100 kilowatt hours of lithium-ion batteries, depending on the chemistry you used. Moving forward to 2009, that's when the NFPA 1 added lithium batteries and nitride batteries. And for the first time, both the codes, IFC and NFPA 1 recognize the need for thermal runaway protection for those lithium batteries. Now, moving forward, between 2009, 2012, 2015, not many changes happened, okay? So what's interesting to realize is as you look across the country, in different parts of the country, different areas go by different versions of the fire code. And so anywhere between 2009 and 2015, your regulations for energy storage systems are essentially the same. Now, moving into 2018, that's not the case. We had big changes happen in 2018. That's when we started seeing more rules for energy storage systems. Rules such as a unit kilowatt hour limitation, like how many kilowatt hours can I have in each unit that I'm installing? And then they wanted to see how far they wanted to regulate how closely we could put those units together. So we have spacing limitations, or spacing requirements, I should say, for minimum spacing between energy storage units. And then if you deviate from those rules, it triggers a large scale fire test. And that's what we know as, the most common version of that is our UL 9540A test method, which we're not going to get into in this particular code corner, but know that that's basically what they're talking about here. And so the other thing that is really interesting to note is it was 2018 was the first time that they introduced residential requirements for energy storage systems. So prior to 2018, there were no residential specific requirements for energy storage systems. But now in 2018, there were. They're not many, and the rules are pretty minimal, like do not put these in habitable space. They want to see them listed and so on. But in 2015, in prior code cycles, there were no specific residential rules. Now, it's interesting to note that most authorities having jurisdictions are enforcing either the 2015 or the 2018 versions of the IFC and IRC. But we have a new code cycle, 2021, which has been released in a couple of areas, or adopted, I should say, by those local jurisdictions. And this is where the energy storage rules get much more strict for installation. And we have a new document that was released, NFPA 855, which is the standard for installation of stationary storage, or energy storage systems, I should say. And the rules that are in that document it's the basis for the 2021 versions of the IFC, the IRC, and NFPA 1. And so they're utilizing that document, which is full of energy storage information, and they're plucking their rules out of the NFPA 855 document. As a result, there's a lot more of them that get employed in the 2021 versions of the IFC, the IRC, and NFPA 1. Now, more and more states are adopting these codes. Right now, it's really California and New York. There might be a couple of other jurisdictions I haven't, caught up with yet that they're pulling into 2021 IRC and IFC code territory. But if you're in those areas, this is where you really have to start paying attention, because the commercial rules are much more intense, and the residential rules are much deeper now than they used to be as well. So we do cover those rules in detail in other classes that we offer. I go through side by side for different jurisdictions, whether you're on the 2015, the 2018, or the 2021 versions of the code. So I invite you to come and check us out, check out our courses. You can find us at education@mayfield.energy. That's our email, or just go to our website and you can look up our educational offerings, and where we dive more deeply into the fire codes for energy storage systems.